Hello everyone and welcome to the lecture on Amazon SageMaker Model Monitor. So this lecture will contain all these topics. What is Amazon SageMaker Model Monitor? Model Monitor types. How Amazon SageMaker Model Monitor works. Monitoring batch transform jobs. Step-by-step setup. Data capture. Data quality and model quality. So what is Amazon SageMaker Model Monitor? Amazon SageMaker Model Monitor helps you keep an eye on the quality of your Amazon SageMaker AI machine learning models while they are actually being used in production. You can set it up to watch your models in different ways, such as monitoring continuously with real time endpoints, running regular checks on batch jobs. If the quality of a model drops or changes, it can change or deviate. The system sends you an alert so you can take action quickly, like retraining the model or fixing issues without having to check everything manually. You can use the built in monitoring tools that require no coding at all. Or if you need something specific, you have the freedom to write your own code for custom analysis. Next topic is model monitor types. So, model monitor provides the following types of monitoring. First one is data quality. So, you can monitor drift in data quality. Second is model quality. You can monitor drift in model quality metrics such as accuracy. Third one is bias drift for models in production. So, you can monitor bias in your model's predictions. And fourth one is feature attribution drift. For models in production, you can monitor drift in feature attribution. How Amazon SageMaker Model Monitor works. Amazon SageMaker Model Monitor automatically keeps an eye on your machine learning models while they are being used in the real world. The system constantly checks for problems and notifies you immediately when any quality issues happen. It uses specific rules to find drift, which means the model is changing or getting worse, and sends you an alert the moment it detects it. This monitoring process works for models that are deployed to real-time endpoints, ensuring they stay accurate while working fast. Next topic is monitoring batch transform jobs. So, model monitor can be used to monitor batch transform jobs as an alternative to monitoring real-time endpoints. Instead of receiving requests to an endpoint and tracking predictions, model monitor monitors inference inputs and outputs for batch transform jobs. So fifth topic is how to set up step by step. To enable model monitoring, you can take the following steps. These steps follow the path of the data through various data collection, monitoring, and analysis processes. For a real-time endpoint, enable the endpoint to capture data from incoming request to a trained ML model and the resulting model predictions. For a batch transform job, enable data capture of the batch transform inputs and outputs. Third, you create a baseline from the dataset that was used to train the model. The baseline computes metrics and suggests constraints for the metrics. Real-time or batch predictions from your model are compared to the constraints. They are reported as violations if they are outside the constraint values. Fourth is to create a monitoring schedule specifying what data to collect, how often to collect it, how to analyze it, and which reports to produce. Inspect the reports which compare the latest data with baseline. Watch for any violations reported, metrics, and notifications from Amazon CloudWatch. Sixth topic is data capture. Data capture is a feature that logs inputs to your endpoint and records inference outputs from your deployed model, storing all this data to Amazon S3. Data capture is commonly used for training data collection, debugging model behavior, and monitoring model performance. Amazon SageMaker Model Monitor automatically passes this captured data and compares metrics with the baseline that you create for the model. You can implement data capture for both real-time and batch model monitor modes using either the AWS SDK for Python, which is Boto, or the SageMaker Python SDK. For a real-time endpoint, you specify your data capture configuration when you create your endpoint. Due to the persistent nature of real-time endpoints, you can configure additional options to turn data capturing on or off at certain times, changing the sampling frequency, and choose to encrypt your inference data. For a batch transform job, you can enable data capture for on-schedule model monitoring or continuous model monitoring for regular, periodic batch jobs. You specify the configuration when creating the batch transform job, with options to turn on encryption or generate the inference ID with your output, which helps you match your captured data to ground truth data. Seventh topic is data quality. Data quality monitoring automatically monitors machine learning models in production and notifies you when data quality issue arises. Amazon SageMaker Model Monitor uses rules to detect data drift and alerts you when it happens. ML models in production have to make predictions on real-life data that is not carefully curated like most training datasets. If the statistical nature of the data that your model receives while in production drifts away from the nature of the baseline data it was trained on, the model begins to lose accuracy in its predictions. The first step is to enable data capture. This captures inference input and output from a real-time inference endpoint or batch transform job and stores the data in Amazon S3. The second step is to create a baseline by running a baseline job that analyzes an input dataset you provide. The baseline computes baseline schema constraints and statistics for each feature using something called as DQ, which is an open source library built on Apache Spark, which is used to measure data quality in large datasets. The third step is to define and schedule data quality monitoring jobs to run at regular intervals. Optionally, you can use pre-processing and post-processing scripts to transform the data coming out of your data quality analysis. The fifth step is to view data quality metrics to access the dashboard and review statistical measurements from your monitoring jobs. The sixth step is to integrate data quality monitoring with Amazon CloudWatch, and that allows you to set up alarms and use a centralized monitoring dashboard. The seventh step is to interpret the results of a monitoring job, analyzing the outputs to understand data quality findings and make informed decisions. You can use SageMaker Studio to enable data quality monitoring and visualize results graphically if you are using a real-time endpoint. And eighth topic is model quality. Model quality monitoring jobs monitor the performance of a model by comparing the predictions that the model makes with the actual ground truth labels that the model attempts to predict. To perform this analysis, the system merges data captured from real-time or batch inference with actual labels stored in an Amazon S3 bucket, enabling a direct comparison between predictions and actual outcomes. To accurately measure model quality, the model monitor utilizes specific metrics that are determined by the specific type of machine learning problem. The model quality monitoring workflows follows the same procedures as data quality monitoring, but includes the distinct additional step of merging actual labels from Amazon S3 with predictions captured from real-time inference endpoints or batch transform jobs. And that's all. Thanks for watching.